Hello and welcome to my demonstration. My name is Vince and I chose for my project to perform a DOS attack, also known as a denial of service attack. I have a Kali Linux machine set up on my virtual box, and I was debating between two main tools to perform this attack, Hulk and Slow Loris. Both tools create HTTP requests at a massive scale and will work in slowing down the web application being targeted. Hulk can create more open requests and faster, but the downside of this tool is that it will complete the request it sends, meaning that it's a one-time attack, and once all the requests are finalized, it's over. Slow Loris does not create as many open requests, but it does leave the request open, meaning that it will constantly keep an assault running until it is stopped. And today I'm going to show you the process I used to attack a DVWA website with the Kali Linux machine and the Slow Loris tool. The first step we want to do is run a basic nmap scan. Now you see here I have ran sudo nmap tac ss tac t4, and then here's the attacking the website I'm targeting. The tac ss, as we've learned in class before, is a TCP send scan. It can perform quickly, scanning thousands of ports per second, and it is stealthy because it's referred to as a half-open scanning, meaning you don't open a full TCP connection. Now the tac t4 is really the speed that I'm running the scan at. The numerical value 4 here, it could range anywhere from 0 to 5, 0 meaning slow and stealthy, and 5 meaning fast and obvious. Now I chose 4 just to make it quick, and we can see here that port 80 is open, TCP HTTP service. That's the port we're going to use to attack. Next, I want to run an LBD scan. This is load balance detecting. This comes standard on all Kali Linux services. So the command is simple, LBD, and then the targeted website. This is going to go through and check load balancing on the website, see if there is any. Load balancing is an excellent way to stop DOS and DDoS attacks. Although this scan does take a little bit. All right, perfect. So it's finishing up its LBD scan. As we can see here, the LBD load balance detector is checking to see if there's any DNS load balancing. You can clearly see right here, it is not found. Another thing, it shows you what kind of what application is running the server. So we can see here that the server is being ran on Apache 2.4. Right here, as it's checking for the HTTP load balancing, It's going through various scans every couple of seconds to determine whether or not that there is any load balancing. It says right here that it is not found. It's checking for the HTTP load balancing differential, and that's going to pop up as not found as either. Now, one thing before we get started on the next step of this attack, which is the actual Python script itself, Slowloris, you can see here that we got the DVWA website up, courtesy of Cameron Delgado. This is pretty cool. You can still see everything. You can access all these different pages. And what we're going to do is prevent that kind of attack, or prevent that kind of access. So now that the scan is done, see, not found. It has no load balancing at all. Now we're going to run the actual attack. The actual attack is fairly simple. It's just a Python script. I had to download it from GitHub. It's real easy. So we start with the command with Python slowloris.py. That's the script. Now TAC P, that's the port we are going to attack. We're attacking port 80. TAC S is the number of open sockets that we are going to be using. Now in a real world attack, if you're trying to attack a website, you're going to probably do more like 1 million open sockets. But for the purpose of this demonstration, and since it's a DVWA, we don't have to do a whole lot. So we're just sticking with a simple 1,000. And then TAC V verbose so we can see what's actually going on. And then finally, the targeted website. Let's go ahead and run the script. Now you can see that it's creating all these open sockets right now. It's going to try to go up to 1,000. I think it stops around 800 just because of the limits of the machine. But if we come over to the website, we now cannot access any of these pages. We're stuck with the spinning icon up top. Really cool. Now if we stop the attack, you can see that pages will start loading up. This attack also stops any scans that are currently happening. So if you're trying to do just a simple scan to see how the operation is going, you can't, because the DOS attack is preventing you. Now one cool thing that Cameron wanted to look at was how this affected the website in real time. So we can see up here the CPU usage on the top is 1.3%. That's standard. That's about what it's running normally. But during the height of the attack, 21.5%. Slowed everything down, took a lot of resources away. Now this is a dramatization. The actual highest we ever got it up to was about 10%. We had to do a little bit of finagling to get it up to 21.5%, just so we can catch something and show you guys what we were trying to, or what we were seeing. And yeah, that's pretty cool. It stops in an instant. You wouldn't even know. Now, ways to mitigate these kind of attacks in the future. Black holing or sinkholing, I do not recommend, because all that does is it takes all traffic and diverts it to a black hole where it's then discarded. That's bad traffic and good traffic, and it essentially shuts the whole site down, which is the whole purpose of a DDoS attack. Now, properly set up routers and firewalls can be configured to stop simple ping attacks by filtering non-essential protocols, and can also stop invalid IP addresses. Routers are typically ineffective against a more sophisticated spoof attack and application-level attacks using a valid IP. Firewalls can shut down a specific flow associated with an attack, but like routers, they can't perform anti-spoofing. Now, IDS solutions will provide some anomaly detection capabilities, so they will recognize when valid protocols are being used as an attack vehicle. They can be used in conjunction with firewalls to automatically block traffic. On the downside, they're not automated, so they need manual tuning by security experts, and they often generate false positives. Now, proper configuration of a server application is critical in minimizing the effect of a DDoS attack, like load balancing. An admin can explicitly define what resources an application can use and how it will respond to requests from clients. Combined with the DDoS mitigation appliance, optimized servers stand a chance of continued operations through a DDoS attack. Another option is over-provisioning, or buying excess bandwidth or redundant network devices to handle spikes in demands can be an effective approach to handle DDoS attacks. One advantage of using an outsourced service provider is that you can buy services on demand, such as a burst stable circuit that can give you more bandwidth when you need it, rather than making an expensive capital investment in redundant network interfaces and devices. In conclusion, DDoS attacks are destructive, stealth weapons that can shutter a business. Our reliance on the internet continues to grow, and proper mitigation, proper configuration of a server is crucial in keeping day-to-day operations running as smoothly as possible.